Alright, hello everyone, Skippy here, and sorry I haven't been uploading these the past few days. I've been working a bit, so this took a bit of a backseat. I believe last video I promised that we would get into the loading of images and the actual drawing of screen, and we're going to start that today. But it's not going to go the entire way. I sort of just worked my way through it, and I figured it was a lot more work than I initially expected. Um, but it certainly can be done within two episodes of these. It's just I spent like about the last hour coding this, getting it through. It's not too much, but I might not have enough time. But without further ado, let's get started. I have this is right here. I split my code up into a master version and I actually working through with this, you guys. So I can actually sort of plan things out more and figure out, okay, not be as surprised as much with additional stuff we need to do and fix a few things. And for reference, since I'm new at this, I'll keep my work over on this side, and then our work we'll be doing is going to be over on this side. I'll reference to what I have over here while we're going through. So first things first, let's take a look at what we have in our UML diagram. Now, you might notice I added a class. This is going to be our tile list, and both our editor and our map is going to be accessing the same tile list. And I do that for a little trick we're going to be doing with our editor for drawing which one we have selected. We're going to need that in order to have a sort of a UI user interface. We need to have access to what tiles we need, and the map needs to have access to what tiles it needs to actually draw. So what we're going to do is we're going to add, right off the bat, we're going to add all our classes to our project. And I'm going to add two I created just right off the bat. So we're going to add a map. And then this doesn't actually have, nope. No. Might be a bit of I have to go into my directory here, and this might be a bit of a hiccup. I expected it to create its own folder for my extra project, but I guess it didn't do that. Now I get to see what I have, everything here. Go to projects, go to C++, and I'm just going to do a very quick and dirty thing. Probably shouldn't be done, but master. Map.cpp. Tile list. All this needs to go into master. And let me guess, it changed this, didn't it? Yes, this has been updated. I will change that from okay. Let me pause this real quick, and I'll get back to you guys. For you, it won't be a second. Alright, we're back. Had a bit of a mess up with my system, but it's all fixed now, and in a very nice manner. What it should have been. Okay. So, like I said, I'm going to keep everything on this, our working project on this side. I'm going to keep this for reference. I might jump over here, so if you guys see any code that might not recognize anything, it's just future work. So like I was going to do, I'm going to add class, and we're going to go ahead and add both our map and we'll just move that over on this side. And then we might as well just go ahead and move and add a what we call tile list. And this keeps a record of what tiles we are drawing. Alright. Oops. We don't need main. We can X that out. We actually don't need map.cpp. You can go ahead and close out map.cpp. We're actually not going to be working on that this episode. Alright, so the first things first, we'll just signal that. I hate these pragma ones. Actually, I like them, but they're not standard, so we don't use them. If not def tile list h define tile. I do wish that would come standard though, that way I would use them everywhere. Because they're actually a really good idea. Makes it much easier to do this, but not standard, won't risk it because not every compiler or preprocessor might support them. Like, I don't think code blocks might not support pragma, or certain pragmas, I don't know. I wouldn't actually know too much. We're going to actually call this tile map. I think calling it map might conflict. Even if you did, even this way it might conflict actually, now I'm thinking about it. On certain projects, but this won't at least be conflicting with the main standard library. Okay, so that takes care of all of that for us. I like to save it. Let's get to work on what our map's actually going to have. First thing is, our map is going to have a void. Oh no, we'll get to that later. Private. And we're just going to have a bunch of ints. Actually, we're just going to call this tiles. So we're just going to have a pointer to an int. And what we're basically going to do with this is it's basically pretty much going to be an array of integers. That's all we're really going to be doing on that. Don't know if we might want to use a vector or something iterable. I suppose we could. But if we know the dimensions, which we actually do need, our int width, height, and then what else do we have over here? We need our tile list. I just call it t-list. Something knowable. And we'll do our include. That takes care of that. And what this allows us to do is, now we are going to do something a bit different. First we need to also go ahead and include SFML graphics. And we're going to do something oddball here. We're going to inherit from SFML's drawable abstract class. And what this allows us to do, and I'm actually just going to, I don't actually know how it's typed, but it's this right here. And you can just search SF : drawable, and it should come up with how to use it on SFML if you like, just Google it. You can also pause the video here, and if you can see it, you know, you can write it out. And I suppose you are able to read it if you're following these tutorials. Although it's not much of a point following the tutorials. and we had that in our map.h here. And this map.cp I thought we closed. Oh, we didn't. We don't need that. Sure. We'll save that. And we'll put that up here. Actually, we'll put that down here. More standard. And I'll go through what this basically does. It is a inherited class from SF Drawable. And it is the only class. The virtual just means that it can be overwritten by a subclass. So if we make a child class that inherits from map, we can overwrite draw for our own purpose. This render target basically when we draw this, it will call draw with and supply a target to render to, and we'll be using that to actually draw our stuff inside of this function. And render states, I actually don't know what that is, but it's important. For some reason, something SFML needs it, and we actually won't be using this class. What this allows us to do is have some really nice syntax in our editor to be able to do, and I'll just do it down here. We have this app. It allows us to do basically that. Just put it in there, and this function draw will take care and use that function. And we'll have it in private just so nothing else can get to it. And drawable is a friend of that other class, the render window, render target actually. So it will actually be able to access this even if nothing else can. Should be able to. I haven't actually tested it yet because I didn't get to a point to test it in all of this. So we'll see if it works, and it should. We'll save that. Now we're also going to add another constructor here. And let's go ahead and actually put this into private. We're not going to be ever making a map without all the data we need. We will make a map, and we will have int for x, int for y, basically our height and width. And then we are also going to supply it its tile list directly. There's no point in really telling it or changing the tile list while we have a map open. At least for our purposes. We won't ever really need to do that. So, even though it might be eventually might be worthwhile, but as far as I'm concerned, we're using integers. We'll never need to have separate tile lists for integers. If you want to make it manageable, then what you can do is you can add a setter function. If you want to change it on your own, you can add a setter function for the tile list. And then what I would actually do to make it a bit more manageable is change this int to char. And everything we're doing with loading up tiles like that, or finding tiles, make it a char. And that might be a bit easier. But that's to do on your own, and I guess it might be your homework. It should be simple to do. And when we're going through the file loading for the maps, I'll show you what you need to change if you're going to be doing it that way. That makes it a bit easier if you want to go tile lists like old school way did it, and want to manage your tiles accordingly. But for now, we can just use ints and just bypass all that. What we will do, however, is add a void load from file char constant char what was it We actually don't even need to name that yet. We can name that later. And we actually probably won't get to that point. We might be able to. But now let's move over to tile list. Tile list, all we're holding here is first include SFML, graphics HTTP. I have a bunch of different ways I'm connecting to graphics to SML here. I have one in my actual. I have so many things I need to fix this. But what we will do in here is all tile this holds is how to put it, is a vector of texture, or not even textures, sprites, textures. All it is a vector of sprites. So we're also going to need to include vector. So std sf sprite list. And then like we did for map, we're going to put our constructor into this into private, so nothing can really access it, and we'll create our own constructor. The perks of writing our own stuff is that we can just use this really specific stuff that we know we're going to be using it for. No one else is going to use it for, like this. So we can do stuff like this and get away with it because no one else can be using our code. If you want to change it, then that's on you. But when we make one, we're just going to create, or take in a vector of textures. And this is going to be a reference because textures are pretty they're pretty hefty since it's holding all the image data, so they can get pretty big. And then also, if we passed in, if we didn't pass in by reference, and we don't want to pass in by reference, this reference, if we didn't pass in by reference, what our sprites hold are pointers to the textures. And if it copied over all the textures, as it would do without putting by reference, it would actually copy it over. As soon as we got out of our constructor, these pointers inside the sprite would break. And then we'd be showing nothing but white blocks. We wouldn't be actually showing an image. So we want to do it the proper way, loading a texture like that. And let's make sure I have everything, yep, like I have here. And then that's what I did. I just went through there. Okay. So we don't need to use this. We can just tile list. Tile list. std sf texture. And then reference text list. Simple stuff. And then I like to use boost stuff. You can do this in a separate way if you don't have boosts. Really, honestly, it is easy to do it. But I use boost. I like boost. Boost is actually pretty neat. I need to explore it more. For each. But for now, we'll do boost at for each. And what we'll do here's the syntax of a for each loop. All we need is, the first thing is we need a reference to what it is we're dealing with. So SF texture and reference, and we'll call this T. And the next thing we need is the container that we want to iterate through. Text list. And so what we'll do each time is we'll create SF sprite S real basic sprite S dot that set text S dot set texture. Something's up here. Oh, wrong one. T. We'll see what happened here. Let me just go to my other text lists. That worked, so this should work. Expression must have class type. Oh, what's the difference? We have an SF sprite here, and then we set the texture. Save this real quick, see if that fixes the problem. And then S list dot push back S. Doesn't look like it recognizes that this is a sprite. Ah, that must have been why. Yep, that was why. I'm too used to Java way of doing things, to be honest. So yeah, that was everything we did on that. And that's everything for tile list, I believe. Because all we really need to do is just access the sprite list every time we just draw it. So what's now going back to our UML stuff. Both map and our editor need to have a tile list associated with it, and then editor actually needs a map associated with it. And I'm just going to throw this out. I have all this down here, but really all I'm doing is creating tile map, pretty much. Basically, I'm just going to do the minimum to show you the basics of what we're doing to draw, and get some inputs moving around, and pretty much just drawing the visible part of the map with this, and then just get a basis to work out the kinks of my sort of screen casting, as well as to sort of get introduced into this kind of way of making games with SFML. And then we'll actually start on the design after that. So we need to add the editor both a map and a tile list, and we have in our map everything. Go to editor, include yep, map, and include tile list. And then what we'll do is we'll add down here our map and tile list. And then what I also did is we're going to keep our textures down here. What we're going to do is we're going to load our textures from the editor class, and we're going to pass them to the tile list when we create it. Then we're going to take that tile list and give that same object to the map class. The map class is going to take that, and it's going to, both the editor and the map will be accessing the same. Well, I don't know if they'll be accessing the same. I know the tile list itself will be accessing the same data. We might be holding two different tile lists themselves, both the map and the editor class, and it's kind of inconsequential since the sprite class is very, very lightweight, and that's pretty much all it's carrying is that sprite class. So it's a very lightweight. It might actually be better termed as more like struct than actual anything else. Even though structs and classes are essentially the same thing as C++. So what do we do? We're doing textures. Texture. And then I keep forgetting this SCD. And then what we'll do here. Oh, I forgot to take this. Ignore this for now. We're gonna delete this, and we're actually gonna re-add it. I forgot to take that out when I was fixing all this. All right, we're gonna make another define here. And what this is gonna do is we're gonna define data path, and say map image or just map, in case you want to do other stuff. We're going to define that variable as data dash image dash map, and that's pretty much going to be the file structure of where it is our oh crap, our image file is going to be found. And we're going to use this to sort of speed up our loading. And we're going to use a C++ trick to help with that. So in our editor, everything's going to be taking place in here. Something is inaccessible. Okay. Why is map inaccessible? You're right there. Should be accessible. But it's saying it's not. What was the path on that? Source RPG, source RPG. Source RPG. Alright. Well, I'll trust to fix that. It'll fix itself. Once we start getting into this. Unless there's even. Is there editor CPP? There is. Should be the one we're using. Okay. We're going to go ahead and go into this and start putting this down. So first thing we need to do is load up our textures. For that, we're going to do text list push back sf texture, just an empty texture, and then we'll do text list that back that load from file. Data path. Oh. Data path map. And then we're going to do something pretty cool here. And what this does is, basically what define does, it takes everywhere where we call this in our code, and it'll just plop this. And so what this looks like here is that PNG, which basically is the same as us doing that. C and C++ allows us to do that, and that's a quick way. That's a nice way to concatenate two string literals. Can't do this with strings themselves, std strings, but constant char arrays that string literal is, you can do that. And I'll leave it there for you guys. And we'll actually do this twice. This time we'll do like pavement. And we'll have like two different images to show that kind of stuff. Alright. Now next that we have our text list, we can implement our tile list. Let's add that. And then we can just pass in text list. And then our map, you pass in, well, we'll pass in what? Let's say, well, we'll hard define it just for now. What you would do is you would poll the user for this information or what size map you want to create. We're just going to create a hard copy map of 20 by 20. And then we'll pass in t-list. And really, that is pretty bad of way of doing it, but for our purposes, just to show you guys, this is how I'm going to do it. You would ask the user though what size he wants, and you'd be using C in, C out, stuff like that. So you'd probably be using the console for that. I would use the console for that. I did use the console for that when I made this actually, the first time around when I was using it for myself. Now, let's try and fix this error. Clear to line 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's not where it was. Oh, okay, I gotcha. It's not this. Ah, why do you need that? That's. I'm very much lost why it needs map like that. Can this work? I don't believe this is gonna work. No, that can't work. Oh. So why do you need this to be accessible when? Well, it's a simple fix. Or, yeah, let's just do that. See how it works. It'll say the same thing for, well, yeah, we never, put in our stuff for, map, did we? Our constructor. I did say forget that. Let's not forget that then. Got it from the right place, right? It should be accessible. I made it accessible just for you. Let's copy this over. And we'll ignore that for now. It might fix itself, might not. I don't actually care if it does or not. And we'll call this int x, int y, tile list, t list. And this will help us with, oh god, looks like we'll have to fix this. This is interesting. Well, let's figure out what you're doing, why you're doing it. So we got map, brings out tile list, which brings out tile list. But let's go ahead and just void this real quick. include it. So wow. Okay, somewhere in here that, oh no, it has it. So it's saying it's an int, which is obviously not true. In our map CPP, we have, I'm going to pass it in my reference. Easier that way. Alright, let's continue anyways. This dot x, this y, and then this t list. And then we'll just equal t list equals y. Equals x. And then we haven't identified. Oh. This is y on this part. That's why. Now, Talus is inaccessible. So, we're just gonna make it accessible because it's complaining. Okay. Yeah, what I did was I forgot the namespace thing, which is kind of important. Oh, wait. Actually, I'm gonna... Okay, my bad. Switch that x and y into width and height. That's actually, that's my bad. And when you're, copying them over, make sure you use, this, or, as, my programming professor in Java like to call it, hiss. It's a T with a hiss. Just to make it more clear, use, hiss, indirection operator, width, or height, or T list. And that makes sure you're accessing the one in the object instead of the one in the function. So let's go to our tile list and fix this. And actually, it's already there for us. So all this is ready to go. We just need to have a load from file function. And what I'll do here is I'll just have an empty load from file function. And then what we also need to do is put our tiles equals new int width times height. Now, if you decide to make this int char, you replace that with char. Replace it with char. It'll create a char array instead of an int array. And then, before we do anything else, we use new. So in our destructor, delete that crap. Delete tiles. We don't want it floating around in our memory, sticking around even after our program's finished. Memory leaks, we do not like it, do not want. Now, it was nowhere. Yep, this fixed itself. And so now, let's see here, there was nowhere else we had anything. We had a state, and that is deleted in here. Our app's deleted in there. In our map, our tiles are deleted. And we do need to create this. And then, it's deleted, and then here we don't have any. Okay. So what we're going to do before we end today, we're just going to create this function real quick. We're not going to create it, but we're going to initialize it. And I don't think we need, yeah, we don't need this virtual, and we don't need that constant. We just need this. And we will actually get to that in next episode. No compilation today, I don't believe. There's no need for it. We can go ahead and delete that out of editor. I went to our editor class. We can delete load map. We don't need it. Yeah, because we removed it from here. Because our map is loaded effectively, or our map's gonna be loaded by probably by our map class itself. We could do it from our editor, but it makes more sense if we're gonna load a map. It's per map, because it'll give us easier access to the integers on there. But okay, yeah. So next episode, we're gonna get to drawing our map. I won't say we'll get to saving and loading a map. That might be the next episode after that. And then it's certainly good. But the next episode is certainly going to cover drawing our map. It's going to have to cover controls for our map. So pretty much the setting our getting our arrow keys, getting our mouse button stuff. That should be too simple. And it will cover drawing and manipulating the view. So pretty much the more important parts of our map stuff, the saving and loading, probably will be the final thing we do before we start up onto designing our actual RPG. So for now, this is Skippy. Like I said, please comment, subscribe. I know my videos starting to be getting a few subscribers. Happy about that. If you like these videos, please comment. Tell me what you'd like me to change or do, or if I'm doing good. Because I actually have no perspective. Because I'm the one making them. You're the one that's actually watching these for one reason or another. So you're the one that's making this for. You're the one I need to. You guys are the ones I need to change or tune the way I do this for. But beyond that, this is Skippy, and I'll be seeing you guys. Thank you for watching.